Good afternoon, everyone.
Afternoon, sir.
All right, so you would see that I have posted for maybe about 5 minutes or so ago some notes on the vertical and horizontal asymptotes, and I just want to read through it. There are 4 bullet points there. You don't have to understand what you read, but just read through it, and then I'll give you another 3 minutes or so, and then I'll come and do the explanation, so we can just run through 1 or 2 more examples. This is one of the last things that we did in class on Thursday. It's another 2-3 minutes, and then I'll take over and just explain what all of those are saying. None of this that is there should be strange, but we will talk about it. All right, guys. So let us walk through the horizontal. I hope this is enough time for people to get home and into a safe place. You see, I'm very generous tonight, so I'm going to be running really very fast through this here. I'm still not seeing. Okay. All right, so we're going to be talking about, what is this? We're going to be talking about vertical and horizontal asymptotes. Now, it says if the degree of the numerator is greater than the degree of the denominator, then the function has no vertical asymptote. Sir, how do you know this? We know this from when we're doing calculus 1, when we're calculating the limit of a function as x tends to infinity, we're dividing by the highest power. Now, the highest power is in the numerator. It means that all the powers in the denominator will be cancelled out. So you may have 0 in the denominator. And you know that you can't have a 0 existing in the denominator. So you're going to have infinity over 0. And any number over 0 makes it undefined. Once you have a 0 in the denominator, it makes it undefined. So once it's undefined, it has no horizontal asymptote. Now, if the degree of the numerator is less than the degree of the denominator, you may have a 0. Once you have a 0, it means that it has one horizontal asymptote. One horizontal asymptote. This is like when you evaluate the limit of a function and it tends to 0. If you're evaluating the limit of a function and it tends to, as it says here, y is the ratio of the leading coefficients. You have a to the x, ax to the n over bx to the n, and the x to the n's cancel out. Then you have a over b. You have one horizontal asymptote. So you'll have one horizontal asymptote when it is that you have the numerator, when you have either the limit of the function working out to a number or a fraction or 0. Once it works out to infinity, it means that you have no horizontal asymptote. Now, if you look at the exponential function, it says it always has exactly one horizontal asymptote. The exponential function has exactly one horizontal asymptote. The parent exponential function is of the form f of x is equal to b to the x. So once you have a function b to the x, that is exponential by nature. But when you have transformations taking place, like b to the x plus 1, or as it says in a general form, a b to the x plus c, that c is going to represent the vertical asymptote, or the vertical transformation rather of the parent exponential function, and that becomes a horizontal asymptote. So this is going to be the vertical thing, vertical because it moves along the y-axis, but that's how you're going to find a horizontal asymptote. You don't have to worry, I'll show you what I mean by it. So if I just give you bx, b raised to the x power, it means that your horizontal asymptote is going to be equal to 0 because there is no vertical transformation. And if when you have something like this now, ax plus a b to the kx plus c, this c is going to be your horizontal asymptote. All right. So it says we do not need to use a concept of limit to determine the vertical asymptote of a rational function. Instead, use the following steps. So we're going to simplify. Let me just copy this one here so you know that I'm talking about the vertical asymptote here. Paste. V-E-R-T-I-C-A-L. Right? So for the vertical asymptote, what we're doing here, it says we do not need to use the concept of limit to determine the vertical asymptote of a rational function. Instead, we're just going to use these two steps. Simplify the rational function, then factorize the numerator and denominator of the rational function, cancel the common factors, and then set the denominator of the simplified rational function to 0. All right? So these are things that we have been doing. This one here, we never normally touch base with by simplifying the function. But you see that in all the other things that we have done, I keep saying to you that the functions don't have to be simplified before you do any sort of transform calculation. In this here case now, we normally use this. We normally set the denominator of the function equals to 0 and then solve. All right, so let us work on a few of these examples to see if we can maximize what is happening here. And let us look at one easy one. It says, use above hint, the horizontal asymptote of the exponential function f of x is equal to 4 raised to the x power plus 2 is y equals 2. So technically, what it is that we're saying, we're finding the limit, because you may know, when you're talking about your horizontal asymptotes, you're finding the limit of a function. For the horizontal asymptote, you're finding the limit of a function. For the vertical asymptote, we are simply simplifying the rational function, then set the denominator equals to 0. So here now, you understand why I'm finding the limit as x tends to infinity, because we're talking about the horizontal asymptote. Talking about the horizontal asymptote, all right? Now, as this tends to infinity, this 4 to the raised to the x power is going to tend, and we are going to negative infinity. We're going to negative infinity, not positive infinity, but negative infinity. Let me put on that as a, oh, come on. All right, negative infinity. Then this 4 raised to the x power is going to go to 0. This 4 to the x power is going to go to 0, so I'm left with 2. Supporting the point here that an exponential function always has exactly one horizontal asymptote. The parent exponential function is of the form f of x is equal to b raised to the x. But when the transformation takes place, when the transformations take place, it can be of the form f of x is equals to ab to the kx plus c. And I'm saying to you that c here is representing the vertical transformation of the parent exponential function. And this itself is a horizontal asymptote. See it right here, so. If something will come after the exponential something, is always a the horizontal asymptote. What's the point I'm making? I don't think they're going to give you a question on the structured paper to find a horizontal asymptote of an exponential function. Because when you see that vertical transformation taking place, 2 to the x minus 2, you know that the horizontal asymptote is going to be minus 2. That's just way too easy. So the man needs something that will be more complex. So everybody understand this example one? That is just really straightforward, that the constant here, C, the constant here, is going to be the horizontal asymptote right here. Any questions regarding clear as mud? Right, I'm happy for that. For this other example, which is what I think we looked at on Thursday, and I want us to spend a little bit more time on it. I only did that because I wanted to defrost your brain on Thursday. But let us look at it a little bit more closer tonight. Let us look at it a little bit more closer tonight. All right. Let's just look at it a little bit more closer tonight. What is happening here is I'm trying to find a horizontal asymptote. I'm trying to, sorry. Okay, let me do the vertical asymptote first. Forgive me. So I'm trying to find a vertical asymptote. Now, the function is simplified as it is. I can't simplify the function anymore. So this simplified function now, I'm going to be setting the denominator equals to 0 and solve. Remember, for the vertical asymptote, I'm setting the denominator equals to 0 and then solve. So I'm setting 2x plus 1 to raise to the second power to be equals to 0. See it right there, so the denominator. And then I'm going to solve it. So I'm undoing the processes. So the first thing that I need to do is to take into consideration that I have a squared term and I need to take off the squared. So I'm going to take the square root of both sides. I'm undoing. Sir, we'll always get a squared in the stuff? No, I can't tell you that. But in this here case, there's a squared term and I'm undoing. I'm reversing the process because my aim is to find the value of this x. So I'm taking the square root of both sides. Now, whatever you do with one side of an equation must be done to the second side of the equation, right? So this is what is going to happen. When I take the square root of this side and this side, of course, the square root of 0 is 0. But when I take the square root of 2x plus 1 all squares, I'm going to have 2x plus 1 to the first power. And remember when we're doing copy. When we're doing, what is wrong? RECAL. Oh Lord have mercy. Undo. RECALL. Remember when we're doing little school mathematics, and we're into or indices and logarithms. Come on now, copy and paste. Remember, when you have something raised to the square root, it is just the same as you are raising it to the 1/2 power. And we did a lot of this when we're looking at the differential equations. We'll look at that when we look at differential equations a lot. So the square root sign means that we're raising it to the 1/2 power. So this here is actually equivalent. Let me put the equivalent sign. It's actually equivalent to what it is that we have on the left-hand side is equivalent to what it is that we have on the right-hand side. And of course, the law says when I have a power, when I have a function raised to a power, which is raised to another power, I multiply both powers. I mean, I multiply both powers. I'm going to get 2 times a half. It's going to be a whole. So I'm going to end up with 2x plus 1. So that works out to be 2x plus 1. Hence, this 2x plus 1. Hence, that 2x plus 1. That's the point I'm trying to make. And of course, the square root of 0 is 0. So I'm going to have 2x plus 1 equals 0. I'm trying to find the value of x. So what I'm going to be doing is subtracting 1 from both sides. When I do that, I'm going to end up with 2x is equals to negative 1. I'm going to have 2x is equals to negative 1. And then I'm going to have divide both sides by 2. X is going to be equals to negative 1/2. So my vertical asymptote here is going to be where x is equals to negative 1/2. I need to find out what my horizontal asymptote is. So my vertical asymptote, when I draw my crosshairs and I'm sketching the graph and I'm drawing my crosshairs, I am going to put, this is negative 1/2. I'm going to put in my 0. I'm going to put in my negative 1. And when I put in my negative 1, I'm going to draw a dotted line through negative 1/2. I'm going to draw a dotted line through negative 1/2. Now I know that the graphs will never ever cross over that line because it's an asymptote. It will never cross that line. That's a barrier. Cannot cross it. All right? Cannot cross it. So I'm going to put in my asymptote. So if you get this thing to do, they're going to give you marks based on you putting in your asymptotes. Right? So you have one already, which is your vertical, negative 1/2. You now need to find the other one, which is your horizontal. Now your horizontal asymptote, how to evaluate your horizontal asymptote? is that you are going to, hold on a minute, please. So what is happening here now? We're finding the horizontal. We're finding the horizontal asymptote. So what we're going to be doing here is finding the limit of the function. Finding the limit of the function. Now, we're finding the limit of the function. And we're finding the limit as it tends to positive infinity. We could find it as it tends to negative infinity too, you know, right? We could find it as it tends to negative infinity. And I'll show you why when we look at the graph again. I'm looking at the function here. It is important for me to expand the denominator. Why, sir? Because, you know, we need to get it in a chain form so that we can go ahead and, of course, you know, when we're finding the limit of a function, as it tends to either positive infinity or negative infinity, we have to divide by the highest power, divide throughout by the highest power of the x function. So when I expand x plus 1 all squares, I am only trying to make this thing easier for you. So bear around with me, please. All right. So look at what I just did a while ago for you. I just reminded you that 2x plus 1 all squares is the same thing as 4x squared plus 4x plus 1. So how do we get that? It's going to be 2x plus 1 times 2x plus 1. 2x plus 1 times 2x plus 1. When I FOIL that, I'm going to end up with 4x squared plus 4x plus 1. And that's what I'm substituting the denominator into. Am I okay so far? Just checking in to make sure that you're with me.
No, sir. That last piece, I see where you get the 4x square, but I don't see where you get the 4x in there.
All right, no problem. Ouch. All right, work with me now. Let me spotlight this so that you can see what is happening. It's like a magic, you know. 2x times 2x is 4x squared. Then this 2x times this one is 2x. And then this one times this 2x is 2x. And that 2x plus that 2x is 4x. And then this plus this gives you 1. Let's go again. No, let's go again. No, let's go again. You say, all right, but
no,
you know, it's all right. May I do it one more time for this?
This is what do you call this? Expansion?
Bob, I was about to say a word that is being very good. Very nice. Yes, sir. I'm expanding. You had lunch today?
Yes, sir.
Yeah, guess what? Anything you did today, do it again. Very nice. Very
Nice,
nice.
sir.
So I'm expanding. So let me just refresh your memories because I know it's a long time. We finish them local school mathematics here. 2x plus 1 all squares is the same thing as 2x plus 1 times 2x plus 1, which is this. And then know what I'm doing. I'm foiling. I'm using everything in this bracket, the first parentheses, to multiply everything in the second bracket. So it means that because I have two things in this parentheses, that means the first sum in this parentheses is going to be multiplied by the two sum them in this parentheses. And when I've done that, I'm going to use the same one, this one, and multiply by the same something in the other parentheses. So each term in my parentheses, in the first one, will be multiplied by everything in the second parentheses. Watch me. So I'm going to use this 2x first to do everything. So 2x times 2x is 4x squared. 2 times 2 is 4, and x times x is x squared. All right? And then 2x times, this 2x times 1 is 2x. Let me see if I can be very cute right here. So I'm try a little magic. Well, if we write one more time, you see, trust me. So it each up nicely. This 2x times this 2x is 4x squares. And watch me now. 2x times 1 is 2x. And this 1 times 2x is this 2x. And then 2x plus 2x are the 4x here. So, and then a 1 times 1 is 1. Tell me, say, see it now.
Yes, sir.
Here as much, sir.
Very nice, very nice, very nice, very nice. So that's what I'm substituting on here. So, and then no, because we're calculating the limit of a function, the highest one is going to be x squared. So we're dividing through everything by x. So do you know this enough? I run through this part now. TT. Oh, need to say something.
Yes, sir.
You're following so far, honey bunches?
Yes, sir.
Yes, good job, CD. Good job. All right. So what is going to happen here now is, by the way, Rashid not here. All right. So I'm dividing through by x squared. So it's going to be x over x squared minus 1 over x squared, 4x squared over x squared, 4x over x squared, 1 over x squared. Them something here. Then we're going to simplify. This x will cancel with 1 of the x squared, with 1 of the x's. See, I put it right here. So the 1 over x squared now have nothing to cancel with, say it right back. The x squared cancels out into x squared right here fully. Nice. But this x cancels out with 1 of the x squares. See it right here. So 1 over x squares has nothing to work with, so we just leave it as it is. All right. So what is going to happen now is when I evaluate here, I'm going to have 1 over x, see it right on here. So minus 1 over x squared, see it right here. So this x squared cancelled with this x squared, so I'm just left with 4, see it right here. So, and then I'm going to have 4 over x, seen right here. So, and the 1 over x squared is going to be a standalone, so we just write it back, 1 over x squared. So we know, remember, once we have a constant in the numerator and an increasing variable in the denominator, it'll go 0. So the 1 here, the 1 here, the 1 here, and the 1 here, see yourself, as x tends to infinity, all of them 1 here will go to 0. So I'm going to have 0 minus 0 over 4 plus 0 plus 0, which is going to be 0 over 4, which is going to be 0. But hold on, sir. If it is equal to 0, it has one horizontal asymptote. But sir, we can just say, as long as it not equal infinity. If it's equal to infinity, sir, it has no horizontal asymptote. But if it equals to 0, that means have 1. And if it equals to a number, it means that it has 1. All right? You know why I'm going back to this? This makes a lot of sense. It's a multiple choice question. This can come out. We can write about 3 multiple choice questions out of this. We can give you all them 3 something here. And then find one next one. We can give 1 to A, B, C, D. All of the following has one, all of the following have one horizontal asymptote, except the one that have one horizontal asymptote, the one that have one, the one that have one, the one that have none. So we can use this to say all of the following have one horizontal asymptote, except, and you have to go look on the one to know, say, the one. So you have to go know the form that A to x to the n, the one that could be equal to infinity. So therefore it's going to be the one that don't have none. So that's one multiple choice. I can find out, I can give you several of these and say to you, all of the following except which one has no horizontal asymptote. So you have to just understand the forms, all right? Don't have to worry, I'm going to send this off to you also. So let's go back to this one here now. So we're going to get x equal, so you know it has only one horizontal asymptote. So what is a horizontal asymptote? Y equals 0. Anywhere on the y-axis, you cross 0, that's where it's going to be. So, forgive me, but we'll draw the graph, the actual graph. But this is what it's going to look like. I have something like this. Oh, I'm on disappearing. I was wondering why when I draw something it go. I don't want that. I don't want no disappearing something. That's my vertical asymptote at x equals -1/2, right? This is my f of x axis, right? At x equals -1/2. That's my vertical asymptote. Graph can't cross a line here, right? But I just got this one here. So if this appears, so if the first one is x equals, if the first one is x equals to -1/2, as we calculated it, it means that the other one is going to be y equals, it will have to be a y value. It can't be another x value. It will have to be a y value. So I'm saying this to say to you that this 0 here is a y equals 0. So the y equal anywhere along the x-axis, y is equal to 0. So my x-axis, this axis is going to be my horizontal asymptote. So if the graph comes this way, it may cross it and come here so and get very close to that, but it can't. It looked like it's touching it, but it's not touching it. So you know that this is your vertical asymptote. It can't cross it. No, it cannot. Cannot. And that's how the general shape of the graph is going to be. All right. I just want to go through the examples first, and then we'll just look at the graph. We're going to be using Desmos, mainly just to look at the shape of the graph in the interest of time, so you can see what is happening. My main interest is just you being able to do the calculations. All right. Now, are there any questions? All right. Won't pressure because I really don't expect any questions. All of what I just did a while ago would have been a refresher for everybody in the class. I would have taught you this before. Now, I'm giving you a new function. F of x is equal to 2x minus 3. I don't want to go any further. I don't want to go up with my page because my solutions for the vertical and horizontal asymptotes are beneath that line. I'm going to give you about 3 minutes to just quickly calculate the vertical asymptote and the horizontal asymptote. No, I'm teaching this because it's on your syllabus. It may not come on an exam, right? I couldn't tell you well answer a question like this, but guess what? With our luck, it may very well come this year. All right, it may come as a multiple choice question, it may come as a essay type question. But let's go. Remember, when you're calculating the vertical asymptote, just check to see if the rational function is written in its simplest form, means that nothing more can cancel out. Once nothing else can cancel out, you're going to set your denominator equals to 0. You solve for the value of x or values of x, depending on what it is. And then you're going to have your vertical asymptote. Your horizontal asymptote may be evaluated when x tends to infinity. And you're good to go. On your mark, get set, go.
Evening, sir.
Hey, how are you?
Tired. Headache.
Sash? Trust me. And so say all of us fall under 1 minute.
Can you scroll to the first example, please? Good evening.
What was that a while ago? Sorry, what was that you wanted me to do?
Can you just scroll up?
When you say up, which one are the up? Like that?
Yeah, one more. Let me check.
Up to that point? Shall I erase here? Oh no. Oh no.
Yes, sir. I just wanted to see one of it before example.
Okay, all right. All right, start off on please.
Sir, you can scroll back up a bit for me, please. You don't mind. Okay, done. Thank you, sir.
I feel neglected. Want to finish it? Hello? Anybody, somebody? Talk to teacher. Oh, I am muted, so they're not hearing me.
Sir, so for me, sir, because I was not here for the classes, I attend the vertical one, but sir, I don't know regarding to how to start the horizontal.
So the horizontal one, as if you are evaluating the limit as x tends to infinity. The horizontal axis, the horizontal asymptote will be evaluated as if you're evaluating the limit as x tends to infinity for the rational function.
Okay.
All right, so I saw that answer in the
Sir.
chat. Okay, good. I saw that answer in the chat, and I'm hearing Charles that she's finished. Let's go. So the vertical asymptote is, why would you say that though? Explain to me why you would think -3. I just want to get, your thinking, Ryan. Talk to me.
Sorry, sir, it's correct. It is actually 3. I had -3, but looking at it, that's it will be +3.
Okay, all right, fine.
Yeah.
All right.
Yeah.
Okay, right. So remember, for the vertical asymptote, what it is that you're doing is two things for the vertical asymptote. You're checking to see if the function is simplified, is written in a simplified manner. Once you recognize that it is written in a simplified manner, as it is here, because you can't cancel the x by the x. Why, sir? Because you have to go divide the 3 by the x also. So that function there is written in its simplified form. That function is written in its simplified form. So in its simplified form, what we're doing is to set the denominator equals to 0. And that's how we evaluate the vertical asymptote. So I'm going to let x minus 3 equals 0, therefore x is equals to 3. Therefore x is equal to 3. Now, Anika, you finished the horizontal asymptote, hon?
Yes, sir, I did it.
Nice. Now, the horizontal asymptote, what did you get, Anika, for the horizontal asymptote?
I don't know if you're right, sir. You get 2 over negative.
Okay, thank you. Me never ask if you're right. We want you to tell me again. All right, very good. Anybody else? Anybody else concur with what you got?
What did she say, sir?
She said 2 over -3. Yes, no, maybe so.
Sir, I never get that.
What you got?
So I only got 2.
2, sir.
Okay, and so did Jermaine. Yes, so the answer is, you remember, no, Mika, You're finding the limit. The highest power that is raised in the variable is going to be x to the first power. So you're dividing everything by x to the first. When you divide everything by x to the first, we're going to have 2 over 1 minus 3 over x. And as 3 over x tends to 0, your x is going to tend to 2.
Yes, sir, see it, sir. It does never match up.
Good job. Very nice. See, you want to understand the topic. Try that one for me.
So.
All right, I'm watching the chat and I'm seeing persons agreeing. Very nice. As I told you, this one here is not difficult. Yeah. Thanks, AC. What is happening here is really not difficult. And this is just to kind of defrost your brain space, from the heavy stuff that we looked at the last time around. And I have an equally, easy stuff to look at. But towards the end of the class, I'm going to touch on something that is which is in another couple of minutes, touch on something that I'm really going to be spending most of the time on come Thursday, God's willing. I'm actually trying to just finish out now the unit 1. And I'm giving you this to do for me, and then we'll take on from there. So start this one for me, please. I give you about a little more, about 4 minutes, 5 minutes at most. Start, please. You're still holding fast to that one? Okay, I would think so too, Yannick. I don't understand why. I mean, I said earlier 3, I think not, and people are still telling me 3 in the chat. Let me just hurriedly go through this stuff here. No horizontal asymptote. This 3 over 0.
That's why I said 0 now, sir.
No, not 0. It's not supposed to be. It's not 0 either. No, it's infinity.
Okay.
It's not even 0. It's infinity. Look back at that for me, please, guys. That's why I said in the chat, 3, I think not. The first part is okay. The horizontal asymptote is what I want to spend a little bit of time on. I'm giving you one more to do for me.
Sir, for the example 4 is because you get the 3 divided by 0 just being undefined, why is no horizontal asymptote?
Sorry. Hold on a minute, please. I still answer you. Hold on. All right, Anika, you were saying something funny about you. Sorry about that.
No problem, sir. I was asking, is it because the 3 divided by 0 that give with the understand why it is no acetone, no horizontal acetone?
Very good. That's no horizontal asymptote. Very good. Very good. Are there any other questions? Is there someone in the class who is not, it's not 100% clear to? Or is it clear as mud? Speak no, because if everything is fine, I'm going to move on. I don't have the time. So I'm going to move on to something else. All right. Now we're going to press the issue. Very well. And then now, one of the things that I wanted to look at is what I'm going to be calling some small change. And how I'm going to be teaching this is just by doing some examples. Pretty easy, so I'm not going to spend much time on it. As a matter of fact, it can be completed within 10 minutes, so I can introduce you to the other area for class on Thursday. God's willing. So I'm looking at some small changes. It says, given that y is equal to 3x squared minus 5x plus 7, we need to find the approximate change in y when x increases from 2 to 2.01, stating whether or not this an increase or a decrease. So, funny story. I don't know how many of you are guilty of doing this, but I know I'm very guilty. I'll go on Amazon and I'll try to buy an item. And I see the item and I say, yes, this is definitely what I want. And I have the item in my shopping bag. And I said, but Lord, we're going to spend so much money on this now. And then the shipping is so expensive. And you want the item, and you're not. And you want the item, and you're not. And you want the item, and you're not buying it. And then when you're ready, finally, to go pay for the item, you see a message coming to say that your item in the cart has increased from $10.99 to $13.99. And it's like, oh, darn, there is an increase in the item. Now, you don't have a choice because you could have buy the item and sent to the people them house long time, but because you're, jokey jam, you don't buy the item, and then after that, you get a telephone call to say, I'm leaving in 2 days. And you say, okay, I'm going to overnight shipping with Amazon Prime. And you wait, and the price goes up even more. And you say, you know what, let me just buy this thing. So you could have gotten it for $10.99 for argument's sake, but you waited until it went to $13.99, and you waited another day and it went up to $14.99. So you're spending $4 more on the item, when it is a could have done it. And I'm not suggesting that you can buy the thing in the first shop because it has happened to me many times. Right about now, if you look into my card, you'll see a few items where the price gone up, and I decided, I ain't buying you until you come right back down. The converse is also true. I remember someone was going up and I was trying to buy a Christmas gift, and I paid quite a bit of money for the thing. And in my headspace, it was a good price. And one of the things, that's why I don't like postmorteming, after an exam. Bought the item was shipped, and I decided that I'm going to go back to Amazon to check to see if, the item gone up, because I don't know if they had said sale or whatever. And I went back to Amazon, and the price of the item went down, and I was livid. I was livid to the point where I said that I'm going to buy that item again and pay the lower price and return the one that I paid a higher price for. But guess what? We never had the time because the person was coming down, right? This is something like that. So there is an increase from $2 to $2.01. So you want to find approximate change. You want to find the approximate change in it, all right? So that's a practical example of what I just gave you with an increase in price. And it could also be a decrease. You don't have to be an increase only. It could be a decrease. Funny thing, I went it could be about October, 1 September, October, thereabout, went to this particular store in Crossroads and saw a nice, we call them stainless steel pot set. And I was like, no man, the food are gonna taste better if I buy this. So I said I was gonna buy it. And I said, you know what? Think about it. Christmas is in about a month and a half, 2 months time. No man, places normally have sale for Christmas. Let us wait until Christmas and we can get a little, 10% off and we save a thing or two. And the person that I was with, she said to me, take a picture of it. I mean, say that makes sense, And we're going to find out if these people are going to put up the price. The pot set was like about, say about $15,000. He said, Christmas come, I want somebody in the class to hazard a guess how much a pot set went to for Christmas.
Oh, 25.
Boy, it's like you're working at a store. The pot set gone to about $23,000. And I said to myself, if I did for me to buy this from Uno, it would have stayed there and disintegrate and turn dust. So sometimes when you see these places talking about we have a sale and so forth and so on, hello, it's no sale. At some point in time, when they believe that the customer is not looking, they increase the price and then claim that they're going to give you a discount. So when you think you're getting a discounted price, you're actually paying for the actual cost of the item, or you even paying more for the item because the pot set was for $15,000. And then it increased to about $22,000, $23,000 thereabout. And I'm saying to myself, wow, just look at that. These guys are crazy. So it can be an increase, it can be a decrease. No, squiggly Y, my squiggly Y here is what I'm going to be calling my increase or decrease. I don't know what it is. My squiggly Y is actually not a dy, but this is a change in Y. It's a squiggly Y, it's a change in Y, it's a small change in Y. And if you look at it, you can see that it's a small change, moving from 2 to 2.01. So squiggly Y, which is a small change in Y. And this X subscript 0 is my initial value. What is my initial value? 2, because it moved from 2 to 2.01. So my initial value there is 2. So my squiggly X is going to be the change that took place. And it's going to be 2.01 minus 2, my initial value, is going to give me 0.01. So my squiggly X is 0.01. Now, look at the formulation. Everything for this topic has a formulation. Know the formulation? Good to go. Squiggly Y is going to be approximately equals to dy by dx times the change. So in order to find the change in Y, I'm going to differentiate the function and times it by the increase. The function is 3x squared minus 5x plus 7. Differentiate this quickly and I want to get
Minus 5.
It's minus 5.
6x minus 5. So it's this 6x minus 5 is going to be multiplied by my squiggly x. See here? The 6x minus 5 is going to be multiplied by my squiggly x, which is a change, which is 0.01. Watch this now. I'm substituting my initial value. So 6 times 2 is 12, minus 5 is 7, times 0.01, 0.07. So it's going to be an increase. Why is it an increase? Let me see if you're thinking. Why is it an increase? Because?
0.01 to 0.07.
Why is it not? Well, that's not what I'm looking for.
It's a positive, not a negative.
Very good. That's what I'm looking for. Very good. That's what I'm looking for, Sash. I want you to say to me that it's positive and not a negative value. Because yes, it could go, yeah, so that's what I'm looking for. So it is positive, so it tells me that it's an increase. No, you will say, but sir, the question don't tell us it's an increase already. Right? It don't tell us a change, it increases from that to that, right? But it also said that it could be a decrease. But we know when I say it is, the question says an increase already because we're moving from 2 to 2.01. Then sir, why them ask you to do an increase or decrease? Hear me out now. So this question was a giveaway because you see, no, let me not tell you.
Sir,
Yes, honey.
I would want you to explain again the squiggly X and the squiggly something.
All right, so the split, fair enough. Before we jump into that other one, I was going to tell you the reason, but I want to see if you guys are thinking tonight. You notice what I've done? Last class was heavy. You notice what started tonight? Very light. Let's go. So the question says, given that y equals all of that, find the approximate change in y when x increases from 2 to 2.01. We need to state whether or not the function is increasing 1 or decreasing 1, or is there an increase in the function or there's a decrease. My squiggly y is going to be what it is that I'm trying to evaluate. My squiggly y is what it is that I'm trying to evaluate. No, my x naught is my initial value. Incidentally, you remember when I was doing Newton-Raphson with you? That, and I think I should have, I think it's important for me to point it out. I don't know why. When I was doing Newton-Raphson with you, this one here had x1. My initial one had x1. Sometimes in the question, they will start it at x0. So here I would say, please know that we're guessing x1 to be 0.5, meaning my first iteration. Sometimes in the question, they may denote the first iteration by x subscript 0. And then the next iteration as x subscript 1. I don't normally teach it with x subscript 0 because I want you to recognize that 1, the subscript is representing the number of iterations. But if the question gives you x0, if they say to you, use x0 as 0.5, you know that your first iteration is going to be x0. So when you do x1, you know that it's going to be your second iteration. So you have to be very consistent with that. All right? Sometimes they give it to you like that. I don't like it that way. And if when you look at the stuff, you see them, the question looking like that, fine. I don't like it like that, but if they give the question looking like that, where x0 is your first iteration, just be very consistent. It's the same way you can work it out. Like I taught you, it not gonna change because I taught you conceptually, but I'm saying to you, the difference is only going to be in your x. So when you calculate x3 is not going to be your third iteration. It's going to be your fourth iteration. That's right. So the only difference with what I taught you, with what it is that they would have given you, is just your numbering. So just be very vigilant on that. I should have pointed it out, but it only came back to me when I'm looking at this one here, right? So I'm looking at my squiggly y. My squiggly y is going to be equal to my differentiated function and finding the rate of change of y with respect to x. And then I'm going to be multiplying that by the change. When I multiply that by the change, I substitute my initial value in it, and it gives me my change in y. So I differentiate the function, I'm going to get 6x minus 5. When I get my 6x minus 5, I'm multiplying it by the change in x. Squiggly x is a change in x. Squiggly y is what I'm trying to find. I'm trying to find a change in y. I'm trying to find a change in this function here, y. So that's why that's squiggly y. Squiggly x is what I'm trying to find. No, squiggly y is what I'm trying to find. Squiggly x is telling me, that this is going to be the difference. 2.01 times, minus 2, which is 0.01. My x0 is going to be my initial value, which is 2. Now, so it's going to be squiggly y is going to be approximately equal to the differential of the function times squiggly x, the change in the x value. 6x minus 5 times 0.01 is going to give me all of this function. I substitute 2 into the function. And I substitute 2 into the function. I'm going to end up with 6 to 12 minus 5 is 7 times the 0.01, which will give me 0.07. And it's an increase because the value is positive. Now, I was going to explain to you how we can get a negative value, but I think we should work a few more questions to see what will happen. I think we should work a few more questions to see what will happen. So I'm going to give you something to do for me. I have yet another question. Given that y is equal to all of that, find the approximate change in y when x increases from 2 to 2.01. Oh, sorry, look at the same thing. Oh, we just differentiate the function and then times it by 0.01, and then we know, sir, and then we substitute to it. Yeah, go ahead and do that for me, please.
I wanted to ask you a question. So,
Go right ahead.
the 2.01 minus 2, is it that you put the increased value minus the initial value?
Yeah.
Okay.
Me kind of like you tonight, because I don't know what happened. Somebody yelling who went out, but you are where I want you to be. Very nice. Don't know if it's right, but you're coming out of your shell. No, man, man, I'm going wicked. I'm going wicked, man. Man, you go easy, Sure. Very nice, though. I am just hearing what it is that you're saying, Ryan. Rich people struggles. I don't know what you're talking about. All right, guys, I give you 1 more minute to finish something, man. Come on, man. 1 more minute and finish it. We want to see if Ryan right. It's we against Ryan. All right, the battle has begun. The battle has begun. I'm seeing 3 answers, and I'm seeing 3 different answers. And the battle has begun. Something like it. Yeah. I'm seeing 4 different answers. 4 different answers. The battle has begun. I'll give you half a minute more to continue fighting. Come, guys, come. The rest of you, only 4 students so far. Drop a thing or 2. All right. 5 answers, 2 people are the same thing. All right, I see another answer. Somebody change them answer. And I see another answer that looked like one of the first answers before. Okay, AV, I see what it is. All right. Love the camaraderie. My answer was negative 0.17. So Charlene changed her answer in the latter part of it. But let me see who first got the, .1, negative 0.17. Anika. Sasha Gay was the first who got the 0.17. Then Anika, then Charles went and did some more calculation and get it. All right, now, I know it's 7 o'clock, but let me ask a question. Is this an increase or a decrease?
Decrease.
Decrease, sir.
Why?
Negative.
Negative, sir. Is a
Very
negative
good.
answer.
Very good. Could you look at the function and see and tell that it was going to be a decrease?
Yes, sir.
Why?
Because of the x in the middle there.
Mm-hmm.
And
What about
the
the
sign that came because when you work it out, it's going to become equal to 1. And it's a negative 1.
Okay.
So
all right.
you realize. Yeah.
All right. So you see that the x squared term, the coefficient of x squared, your highest term was already negative. So you cannot get a clear indication that the answer chances are going to be a negative value. In this case here, you see that your answer is the coefficient of x squared is positive. Chances are you will get a positive value. All right. So very good. Do tell me, was that difficult?
Sir.
No, sir.
No, sir.
No, it wasn't. All right. That's it for tonight. We officially, I didn't even start a new topic. We officially have completed applications of differentiation. What we're going to be moving into on Thursday, God's willing, will be applications of integration. Now, you see, between now and then, go and brush up on your integration skills, please. And thank you. I beg of you. Just brush up on your integration skills, please and thanks. All right, what I'm going to be doing after this is I'm going to see if I can send you the notes for this one here and maybe generate one or 2 practice questions. Yes, sir. Oh, yes, sir. Thank you. Right.
Thank you. Yes, sir.
Right. Good. I thought it was a question, but I got it afterwards. Yeah, man, no problem. Have a good one. There was something, I was in a meeting and I was going to share something with you guys, but guess what? It just eluded me a while ago. I'll drop it in a WhatsApp group when it comes back to me. Have a good one. Please, guys, make sure that you are studying. Don't allow the calculus 2 to run away and leave you or any of the other courses that you're doing. Stay afloat and you're good to go. All right? Have a good one. Bless up.
Yes, sir. Same to you.
Sir.